Welcome to the world of network automation. In this video, we'll explore how to use Python and application programming interfaces, also known as APIs, to transform network management. We will see how we can leverage the power of Python, APIs, and networks to automate most of the network-related tasks. Why should you care about network automation? Let's discuss some key benefits. First, efficiency. You can reduce manual configuration time from hours to minutes, automating repetitive tasks across multiple devices simultaneously. Second, consistency. Automation eliminates human errors in configurations and ensures standardized deployments across your entire network infrastructure. Third, scalability. Manage growing networks without a proportional increase in effort. Deploy changes across thousands of devices with ease. Fourth, agility. Respond to business needs faster by implementing network changes in minutes instead of days or weeks. Python has emerged as the go-to language for network automation due to its simple syntax and availability of powerful libraries. Key libraries include Netmiko, and NAPALM, which we will explore further. Python excels at parsing and manipulating data, making it ideal for network-related tasks. Plus, it has extensive community support and documentation. Here's a simple Python script using the Netmiko library to connect to a network device, establishing the device connection parameters such as device type, host, username, and password. Then it connects to the device and runs a command such as show IP interface brief and prints the output. Let's explore network APIs. APIs, or application programming interfaces, are essential for network automation as they allow different systems and applications to communicate with each other and exchange data. Here are some common network APIs. REST API, which is an HTTP-based stateless API, which uses JSON or XML data. netconf, which is an XML-based connection-oriented protocol. gRPC, a high-performance remote procedure call framework. RESTconf, a REST-like interface for netconf. And OpenConfig, a vendor-neutral data model. Here's an example of a simple REST API request to a Cisco device using the request library in Python, defining the API endpoint URL, setting the headers for accepting JSON data, and providing authentication credentials. This code then makes a GET request to retrieve interface data from the device. Let's delve into REST API basics. REST APIs use HTTP methods to perform different actions. GET is used to retrieve network data, such as interfaces and routes. POST is used to create new resources, such as VLANs or access control lists. PUT is used to update existing configurations. Delete is used to remove configurations or resources. And patch is used for partial updates to configurations. Here's a Python example of a GET request to retrieve interface data. The code defines the API endpoint, sets the headers, including the authorization token, and makes a GET request using the requests library. If the response status code is 200, it processes the JSON response and prints the number of interfaces found. Netmiko is a multi-vendor SSH connection handler built on the Netmiko SSH library. It supports over 20 network vendors, simplifying SSH connections, handling command timing and prompts, and managing configuration modes. Here's a basic Netmiko example. First, we need to import the connect handler from the Netmiko library. Then we define the device parameters such as device type, host IP address, username, and password. Finally, the code connects to the device using the connect handler and sends the show version command and prints the output. NAPALM, short for Network Automation and Programmability Abstraction Layer with multi-vendor support, provides a unified interface for multiple vendors like Cisco, Juniper, and Arista. It offers configuration validation, comparing running versus intended configurations, and supports atomic changes with commit and rollback functionality for safe deployments. It also returns data in a consistent JSON format. In this example, we will get device facts from a network device using NAPALM library. First, we select the appropriate driver, such as iOS for Cisco devices. Then we connect to the device using hostname, username, and password. We open the connection and retrieve device facts using the getFacts method, and then print the results. Let's discuss the automated configuration process. It begins with generating configuration templates using Jinja 2. Then store device-specific variables in YAML or JSON files. Next, render templates with device variables. After that, validate configurations before deployment. Finally, deploy with commit or rollback capability. Here's an example with Jinja 2. The code loads device data from a YAML file, loads the Jinja 2 template, and renders the template with the device data, generating the final configuration. When implementing network automation, it's essential to follow best practices for error handling. Always use try and except blocks for network operations to catch and handle exceptions gracefully. Implement timeouts for all network connections to prevent scripts from hanging indefinitely. Verify changes with pre- and post-validation checks to ensure the desired state is achieved. Implement comprehensive logging for all operations to aid in debugging and auditing. And always have rollback mechanisms for configuration changes to revert to a previous known good state if something goes wrong. Here's an error handling example. The code configures logging, then attempts to connect to a network device and apply configurations. If a Netmiko timeout exception occurs, it logs an error message. The future of network automation is bright. Here are some emerging trends and technologies to watch. Intent-based networking, which is networks that understand business intent and automatically implement, verify, and remediate configurations. Artificial intelligence and machine learning for networks, predictive analytics for network issues, automated troubleshooting, and intelligent optimization. Infrastructure as code, network configurations managed as code repositories with version control, and continuous integration and continuous deployment pipelines. Event-driven automation, networks that react automatically to events and triggers without human intervention. Network digital twins, virtual replicas of physical networks for testing changes before production deployment. And zero-trust automation, automated security policies that verify every access request regardless of source. Some useful resources include Netmiko documentation, NAPALM documentation, and network programmability and automation books. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.